Okay, so next up we've got Greg Hesse, and he's our C2 Australian Panel Convener for Power System Operations and Control.
Thank you, Angela. Thanks, everyone, for the opportunity to be here this afternoon on a sunny afternoon in Sydney. Study Committee C2, our scope. And what's really interesting about C2 compared to a lot of other study committees is it's not just the technical, it's also the human resource and the institutional aspects and how they all come together. So as power system operators, we live at that intersection of the technology, the people and the systems and how they all come together to deliver an end result in terms of a reliable and secure functioning power system. Every year when I give these presentations, I try to put up a different photograph of a control centre from around the world. After the Paris session, I had the good pleasure of visiting the National Grid ESO Centre in, just outside London. And this is their main control room. Probably doesn't do it justice because you'll look at that and go, there's an awful lot of empty desks. Where are all the people? The answer is they actually run a dual control centre operation. So for any given shift, not everyone is all in the same room. They're part in one room, part in a different location. Whoops, I'm waving us around too much. But what was really interesting when I got to go there and talk to some of the people there and view the control room, basically that view from the viewing platform, is National Grid ESO, they're harnessing all of their human resources. On that particular shift, the shift manager, so the person with overall responsibility for the reliability and security of the entire Great Britain grid, was a lady. It was fabulous. And one of the main centre desks with central control for dispatch was a gentleman in a wheelchair. I'm thinking, that's diversity and inclusion in action, harnessing all your human resources that you can do, using everyone to their best ability. I just thought that was really fabulous to see that. Turning to the structure of our C2 group, we structure ourselves through 3 domains of work, and they're colour-coded on this diagram. The green refers to the real-time system operation and control, so that real-time inside the control room area. The orangey sort of colour, doesn't show quite so well here as it does on paper when you print it out, is the sometimes known as operational planning, or that system control, planning, performance analysis. So the things that happen outside the control room in preparation for the real time. And the yellow is the technical domain relating to those control centre infrastructure and the human resource aspects of system operation. So C2, compared to a number of the other study committees, doesn't have huge numbers of working groups in operation. These are the 6 that we have currently. We do a number of joint working groups with adjoining study domains, quite often with C4 around power system performance, C5 around the interaction of markets and regulation with system operation. Increasingly, I think as we go forward, we'll probably look to D2, the cyber security interactions. But we are definitely on the lookout for new working groups, and we'll talk a little bit more about that. The publications in the last year, again, I think probably COVID effect has come to the fore as well. One technical brochure finalised during the year, and the importance of this one around the mitigating of fire starts. Frank Kriske from SA Power Networks was the convener of that group and did a really good job. And Frank had was invited to make a technical presentation at the C2 Study Committee meeting in Paris, which was quite well received and provided a lot of really useful information for those who were attending. Two tutorials during the year, finalising the outcome of previous working group activities. So at the Kyoto Symposium, that tutorial on the impact of the high penetration of inverter-based generation on system inertia of networks and some of the operational implications of that. And in the Paris session, we had the Mike Power from Ireland presented on the TSO-DSO cooperation and the control centre tools of the future that we'll need to deploy as we increasingly see this explosion in distributed energy resources and two-way power flows and all this complexity around the transmission to distribution interface. Also at the Paris session, one of the highlights each time is the Large Disturbance Workshop on the Monday afternoon. This is a joint session between C2 and C5. Large number of events, and we always try to look for events that in the one event you can see both a power system operation aspect as well as a market aspect if we can. That's what we try to achieve. Some of the really interesting ones, European system split. When you think about a power system the size of continental Europe and the number of parallel paths, to actually have a system separation event is highly unusual. There have now been 2 in 2 years, including different parts of the continental Europe network. The one that was discussed this year was a separation of the Iberian Peninsula, so Spain and Portugal, separating from France as a result of wildfires along transmission corridors. And one of the interesting things about this one was there was maybe 2,000 megawatts flowing from France towards Spain when the event happened, but it triggered about 4,000 megawatts of under-frequency load shedding. So you start to see the effect of these low inertia power systems that you can't pull the frequency up quick enough, and you go deeper into that under-frequency load shedding before you can pull it up. The Israeli system split, the so-called Dragon Storm, and I think more than one person in the room observed that if you're going to give a weather event a name like the Dragon Storm, you're probably asking for trouble as a result of that. And a couple of local events around New Zealand, and that's the chart I've put up on there, where the orange line at the top is your available generation and the blue line coming up to meet it is the consumer demand, and where the two meet you've got effectively zero reserve, so running very, very close to the wind in that New Zealand event. In terms of Australian contribution into the group discussion meeting, through the process, we think we started with 3 synopses submitted, 2 papers prepared, one of which was finally accepted, which again is showcasing where Australia can be leading the world in our experiences with some of this low demand in isolated grids, particularly being South Australia, and how we manage some of these minimum demand, minimum inertia, minimum fault level type situations. We had the 2 prepared contributions, which were really calling out our real-life practical operational experience with battery energy storage systems, again in South Australia primarily, and I had the good pleasure of being special reporter for our preferential subject 2. Some of the key themes that came out of the group discussion meeting relevant to the energy transition. Louise, I think, spoke a little bit earlier about AI and machine learning. And we had a fair bit of discussion about their emerging role in operations. And like some people, probably the Elon Musk of the world, it's like, well, you won't need a human operator, you'll have the machine do it. The analogy that was given was, well, there's a lot of smarts in commercial aircraft these days, but no one seriously considers that you're going to take the pilot away and just leave it to the machine to fly the plane. There's always that human factor that to make those difficult trade-off and decisions that can be required. The other one that got a lot of airplay was the subject of network topology optimisation. So as system operators, the more bits of network we can have in service, the better we feel, the network's resilient, etc. Having additional open points to channel flows into one part of the network or the other sounds a bit anathema, but in a much more highly variable power system with these variable renewable energy sources, moving huge quantities of energy into storages and out on a daily, weekly basis, the prospect of having to more dynamically change the topology of the network, whether it's on the distribution network or on the transmission network, I think will be coming into increasing focus as we move forward in the transition. So that's an area to watch out for, I think. I mentioned before, Frank Kriske made this technical presentation to the study committee meeting, again very well received, well worth a read having the technical brochure. You'd recognise that probably traditionally bushfire or wildfires, as they're sometimes referred to, it's probably a subject of interest to a relatively small number of countries around the world. Australia, obviously, West Coast US, again the Iberian Peninsula, Spain and Portugal, Greece. But it was coincidental that as this working group kicked off its work a couple of years ago, you actually had wildfires being experienced in some non-traditional areas like Sweden and places like that. So I think it highlights to people where they need to start thinking ahead in a world in transition and climate change, and if things are changing, here's an opportunity to get ahead of the curve. In terms of working groups, recently started a joint working group with B4 looking at the operational impacts of offshore wind power systems, particularly hybrid AC and DC configurations. Talking about possible new working groups. My colleague from AEMO, Nilesh Modi, who's here today, has helped put together a draft of a terms of reference for a working group looking at operational strategies for managing those new minimums. One of the things as system operators you get used to over the years is when you've got high demand and things are under stress, well, if worst comes to worst, you can always load shed your way out of a problem. You can reduce demand. But when you haven't got the demand to begin with, you can't always put extra demand on the network. So how do you manage these minimum demand, minimum inertia, minimum fault level, minimum reactive control sort of conditions? Other ideas that are being discussed for new working groups around operational resilience indices. I hear the word resilience has come up a couple of times today, certainly in C1, which is great. The cyber security aspects around system operation, again, the thinking about increasing data interchange across interfaces between entities, transmission, distribution, across to end consumers. How do we facilitate that, but in a cyber secure manner? What are the tools, the mechanisms, the protocols that we need in place? And of course, are there system operational implications for changing in climate policy and those sorts of things, environmental aspects that maybe there's some work we can do with C3? Turning to our Australian C2 areas of interest, so we had a mid-year teleconference session preparing for Paris, and talked about a fair bit about the battery energy storage systems because they were getting a lot of airplay through the special report and the papers that were being discussed. So there's significant interest across all of the networks about operational applications for battery energy storage systems. How can we best use them in an operational sense? The operationalising of inverter-based resource control systems. So we are increasingly reliant on these third-party systems, widely dispersed in order to maintain our power system security. And how do we maintain that security when the OEMs often maintain access to firmware upgrades, those sorts of things? How do we have that degree of assurance that we always enjoyed with the large central power stations in this much more dispersed digital world? And AI applications in the control room. How do we move from that informing to advising, and dare I say it, even to actioning as a result of things that are being observed? I'm sure this keeps moving on. We're already discussing, we had our panel meeting yesterday, and already discussing ideas for papers for the Paris 2024 session based on the draft of the preferential subjects. Those preferential subjects relate to operational resilience to extreme and unpredictable events, so opportunity to share the Australian network's experiences of how we manage extremes of flood and fire and cyclone. And the other preferential subject is relating to changes in system operation and control considering the energy transition. So how do we need to change our mindsets in terms of operating the network as this transition or transformation unfolds? And with that, I will leave it for C2.